extension, so we're not going to do the whole thing. We're just going to do one of the examples. So in this lesson, we extend the factoring of polynomial expressions to examples where the leading coefficient is not 1. And it says these examples can be regarded as an enrichment for students following the Alberta curriculum. That's true and it's not true. So what's going to happen is you do need to be able to things that have a leading coefficient that is not 1, but it will always have a factor that is just, that has a 0 that is a factor of that leading term. So in other words, one like this where both factors have numbers in front, we don't need to do. We need to do ones where we have at least one factor that does not have a number in front of the x, even though some of the other ones might. So there's an example like that. This one. Example 1. We have this 5x cubed minus 51x squared plus 55x minus 9 equals 0. So we're just going to check anything that's a factor of 9. So that'd be 1, 3, and 9. Now we're guaranteed, if you're given this question in the course, that one of these will work. This is not actually the whole list of potential zeros, but it'll get us at least one of the factors. So, and then it says, show that x equals 1 is a 0 and determine all the zeros. So if x equals 1 is a 0 and we divide it out, we'll be left with a quadratic we can factor. So we have 5, negative 51, 55, and negative 9. It's 5. Adding gives me negative 46. Adding gives 9. 0. So now I can write this polynomial as x minus 1 times 5x squared minus 46x plus 9. Well, now we need to factor this quadratic. So we are looking for two numbers that multiply to 5 times 9. So multiply to negative 45 and add, multiply to positive 45 and add to negative 46. Well, I'm going to do that factoring on the side here. So negative 45 and negative 1 would add to negative 46 and multiply to positive 45. So we use those to split up the middle term. And we factor by grouping. So we have 5x times x minus 9 minus 1 times x minus 9 gives us factors of x minus 9, 5x minus 1. So this in factored form is x minus 1 times x minus 9 times 5x minus 1. So you'd see that the 0 from this factor was in the list we made, the 0 from this factor was in the list we made, the 0 from this factor was not, but we can still get to that factor because we found those ones first. Now this really asks us to find the zeros. So the zeros are 1, 9, and 1/5. Solve the equation. Well, if that function is equal to 0, those are the same values we just found.